Good morning, boys and girls, and welcome back to our next lesson on the rules of differentiation. Okay, here's where things will start to become a little bit nicer. Probably the day you've been waiting for, where we won't have to keep using all this limit notation anymore. All right, so let's start with our very first rule, the constant rule. If you take the derivative, it's not writing, the derivative with respect to x of a constant number, that is always going to be 0. Okay, here's a quick little proof of this. We talked yesterday how the derivative is also the slope of the tangent line, right? And so if I look at the function of a constant number like, y equals 3 or f of x equals 3, the slope of the tangent line anywhere on this graph is going to be 0, right? At any point I pick, tangent line there, that's going to be 0, okay? So the constant rule says whenever you take the derivative of a constant, that is always 0, something we just need to know. Okay, next, before I bust out the big daddy rule of them all, the one we really want, I'm going to go ahead and I'm going to work through the derivatives of these two functions, x and x squared, using our limit notation, all right? Okay, so here we have our first one. I'm using the limit definition of derivative, the limit as h approaches 0 of f of x plus h minus f of x all over h. So if I find f of x plus h, I plug x plus h into f of x, and so I just get x plus h, minus f of x was x, all over h. Those x's kill off, so I get h over h, and then the limit as h approaches 0 of 1 is 1, right? So the derivative f prime of x then would be 1. All right, now moving on to our second one. Here we are with the second example. The limit as h approaches 0 of x plus h squared minus x squared all over h. Again, I'm going to plug my g of x in, right? G of x plus h. So I'm going to plug x plus h into g of x minus g of x all over h. I square that. I end up with that. The x squared minus x squared kill each other off. So now we're left with just 2xh plus h squared. And I factored out an h. Now the h's die off, and so we're left with the limit as h approaches 0 of 2x plus h, which tells me that, hey, g prime of x would equal 2x. All right? And we can keep doing this. Again, all these rules that we're talking about right now all go back to this limit definition, okay? Any of the rules that we talk about moving forward, whether it be the power rule, sum rule, product rule, quotient rule, any of these rules, we all would have to justify through limits because the definition of derivative first starts with its limit definition. Okay? But here's the big rule that we've all been waiting for. Dun 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 dun! The power rule. All right? The power rule states that if you're going to take the derivative of an x to some power, what you're going to do is you are going to move that power in front, and that becomes a coefficient. And then you have x, and then you take 1 away from the power. So going back to the 2 we just did, we said, hey, f of x was x. So if I do this, and if I take the derivative of this, the exponent of 1 comes in front, and then I have x, and I take 1 away, so that'd be x to the 0, which is 1. So I get 1 times 1, or 1. Okay. For the g of x was x squared. So if I take the derivative of g of x, I'm going to take that exponent of 2, I'm going to put it in front, and then x, and then I take 1 away from the exponent, so 2 minus 1 is 1, so 2x. And so that's a lot faster way than all that work I just had right before, to find those derivatives. Here are a few more quick examples. If I say h of x is x to the 4th, if I'm going to take the derivative then of h of x, this would be 4x, and then I got to take 1 away from the exponent, so 4x to the 3rd. And this works for all kinds of stuff. I don't know. I'm running out of names, so I'm just going to change colors. And we'll do a red f of x. All right? So in this case, f of x is, the square root of x. You might be like, well, that one doesn't have a power, but I guess I could rewrite this as f of x equals x to the 1/2. And now I can apply the power rule to this. If I took the derivative of this, hey, f prime of x equals 1/2 x, and then I got to take away 1, so 1/2 minus 1 is negative 1/2, and there would be my derivative. It even works with, it even works with green g of x, x to the negative third. Okay? If I want to take the derivative of this, g prime of x, I put the coefficient in front, x, take one away, so that would become x to the negative 4. Okay? So we can use the power rule and all sorts of stuff. It makes our derivatives real nice and easy and a lot of fun. Okay, here are 3 more rules coming at you. The constant multiple rule, the sum rule, and the difference rule. Okay? These kind of stem, again, from our limit rules that we talked back in our last unit. But basically what the constant multiple rule says, if you have a constant multiplied by a function, and if I've got like my x squared and I got a 3 in front of it, 3x squared now, what you can do is you can pull that constant out and just kind of ignore it, take the derivative of the x squared, and then multiply the 3 back in when you're done. Okay? You can ignore a constant in front and just take a derivative of the function and then add the constant there when it's all said and done. Okay? Just like we can do with limits. The sum rule says that if you're taking the derivative of 2 things adding together, you can take the derivative of each of those things individually. This allows us to take the derivative of polynomials and other functions like that. And then same thing with the difference rule. If I'm taking the derivative of 2 things that are subtracting from each other, I'm taking the derivative of x cubed minus 5x squared, I can take the derivative of each of those things separately and subtract them from each other when I'm all said and done. Okay? So constant multiple rule, sum rule, and difference rule. All right, and 3 more last little rules that we want to be aware of. The derivative sine, derivative cosine, and derivative of e to the x. All right? If you take the derivative of sine, the derivative of sine is cosine. I guess I don't need to write it out. All right? If you take the derivative of cosine, it is negative sine. So watch out, those are a little confusing to begin with. And then this one's my favorite one, though. If you take the derivative of e to the x, that's e to the x. It stays the same. That's beautiful, right? So 3 derivatives that you want to get down, know, and have memorized right there. Derivative of sine, cosine, and e to the x. All right, let's do some examples. Okay, number 1. G of x equals e to the third. Find the derivative. This is one of my favorite ones to have you guys do in class a little bit because everybody gives answers like, hey, it's e to the third. We just talked about the derivative of e to the x is e to the x. However, this is not e to the x, this is e to the third. And e to the third is a constant. So if I took the derivative of a constant, that derivative is 0. Okay, next one is f of v equals v to the 100. If I want to take the derivative of f of v, again, this would be the power rule. So f prime of v would be the power becomes the coefficient, v, and you take 1 away. So 100v to the 99th. Okay, our next one is g of w equals 5 over 6 w to the 12th. In this case here, this is a mixture of the power rule with the coefficient rule, okay, or the constant multiple rule. What we're going to do here is you just you can ignore that 5 over 6 in front technically, and like that's just going to hang out. I'm going to take the derivative of w to the 12th, so times 12 w to the 11th, and now I can multiply that stuff together. And so g prime of w would be 5, 6 times 12 is 10 w to the 11th. Okay. What we end up doing is we don't write it out like that, where we just ignore that constant multiple in front. We just end up going, hey, 12 times 5 over 6 is 10, and then w to the 11th, and subtract 1 from the exponent. We kind of just move it all along at once like that. But we're technically using 2 different rules there, so I just want to illustrate that. Okay, here we go. Our next one, f of t is 6 root t minus 4t cubed plus 9. I think, like we talked about earlier, if I were going to do this one, I would rewrite this as 6t to the 1/2. So I'm going to be able to use my power rule. And now we're going to use the power rule combined with the constant multiple rule, combined with our sum and difference rule. And I'm just going to take the derivative of each of these things individually. So if I take the derivative, again, make sure you notate properly that now I'm taking the derivative. That's no longer f of t. But now I'm taking the derivative. 1/2 times 6 is 3t. Now I got to take away 1, so 3t to the negative 1/2 minus 12t squared. And then the derivative of a constant is 0. So there's the derivative right there. Derivative of 9 is 0. Okay? The only thing with this answer, like, this is a perfectly good answer, but you might want to just make sure, check, double check, like as you're checking yourself in the back of the book or whatever, make your answers match. Like, I just went and checked this answer, and that's not the answer they had in the back of the book. And there's definitely ways I can manipulate this answer. Like, there's nothing wrong with that if it's a free response, but if it's multiple choice, you're going to have to make it match, so practice doing that. But this negative exponent would really send it to the bottom. And then again, because it's a 1/2, that's really a square root on the bottom. We don't have to rationalize, but this is the answer they had in the back of the book. So make sure you can make your answers match what is there. Okay, here's our next one. F of x equals 2x plus 1 times 3x squared plus 2. There's actually another rule that will apply to problems like this down the road called the product rule, but we don't have that rule yet. That's something we're going to build towards. So if I want to take the derivative of this thing right now, I can't do it the way it looks. So what I would have to do is I want to multiply out first. Okay, I'm going to go ahead and double distribute, and so I'd get 6x cubed plus 4x plus 3x squared plus 2, or 6x cubed plus 3x squared plus 4x plus 2 if I put it in the right order. So that's my f of x. And now that it's in this form, we could go ahead and take the derivative of this just by using our power rule. Multiply the front by 3, I get 18x squared, subtract 1, plus 2 times 3 is 6x, subtract 1, plus 1 times 4 is 4, and then the derivative of 2 is 0, so that part goes away. So the derivative would be 18x squared plus 6x plus 4. Okay, this next one is something that we are going to do a lot of. We want to write the equation of the tangent line of the given function at the given value. So I want to write the equation of the tangent line to y equals negative 3x squared plus 2 at a equals 1. Okay? Whenever you're told to write the equation of a tangent line, the first thing I want going through your mind every single time is I'm going to write the equation of any line, generally tangent lines, but any line, I need a slope and I need a point. And so I always start things out like this. Hey, I got to find a slope and a point. And if you're going through that thought process, it's going to make all the different variations of this kind of problem a lot easier on you. So whenever the directions say write the equation of a tangent line, write down I need a slope and a point. Okay? Now to find the slope of the tangent line, that is going to come from the derivative. Again, remember derivative is a synonym for slope of the tangent line. So if I find the derivative of this function, I get negative 6x. Okay? And then I need a point. We're going to come back to that in a second here. I also need a point that I'm going to plug into there. And so I know I want it at a equals 1, so that is my x coordinate. So I need to go find the y coordinate by plugging into y. And I get negative 3 times 1 squared plus 2, or negative 3 plus 2, or negative 1. All right, so now I've got a point. And now I just need the slope, y prime, at 1. And so this is negative 6 times 1, or negative 6. So now I have my slope, and I have my point. Okay? Once you have that, then you can write the equation of the tangent line. Y plus 1 equals negative 6 times x minus 1. And there's the equation. Again, I would stop right there unless you need to make your answer match the back of the book. Maybe I got to put in slope-intercept form or something. Okay, one last little problem here that I want to talk about that deals with some different notation that you might not be used to. I have a giant table here of x values and the derivatives of f and g at various x values. And down here we're asked to find the derivative of f of x plus g of x. This little line here means evaluated at x equals 1. Okay? So if I want to do this, I would first take the derivative of my stuff. So the derivative of this would be f prime of x plus g prime of x. And then I want to evaluate this at x equals 1. So I'm really trying to find f prime of 1 plus g prime of 1. So now I'm just going to use my table to evaluate this. F prime of 1 is 3, g prime of 1 is 2, and 3 plus 2 is 5. All right, that's it, boys and girls.